Today, Team 5 will be presenting a presentation on the predictors of housing prices in King County, Washington, USA. Our team consisted of Yasaswi, Naaman, King, Akash, and myself, Catherine. The agenda for today will be as follows: an introduction of our data set. Then we will describe each of our variables using various graphs and techniques. Then we will run a correlational analysis with each of our independent variables and price. Then we will run a multiple regression with all of our variables. And finally, we will interpret our results and give further recommendations. In Part A, our goal is to investigate how housing prices have changed between 2014 and 2015. We also want to understand the distribution of our dependent variable and independent variables. We want to examine if location within King County affects price and understand the impact a waterfront location has on price. And finally, we'll examine the difference in price between homes that are renovated and non-renovated homes. A little background of King County. The city of Seattle is located in King County, Washington. King is the most populous county in Washington and the 13th most populous county in the U.S. As of the 2010 U.S. Census, there were 1,931,249 people living there, 789,232 households, and 461,510 families residing in the county. Many tech companies, such as Microsoft, have home offices in the county. It is the home of 6 Fortune 500 companies, including Amazon and Starbucks. We also picked this county because it shares the name of our group member, King, who hopes to one day live and work in this area. Our data set was found using Kaggle.com. The data was housing prices of homes sold in King County between 2014 and 2015. 19 variables were measured in this data set. We are going to use this data set to predict housing prices in King County. However, our data set is only representing those houses that have actually been sold. Thus, it is not a random sample. The data set is a population sample of prices of houses sold that we are using to represent the prices for all houses in King County. The following table is a description of all of our 19 variables that were found in our data set. We used a histogram and a box plot to describe our dependent variable, which was housing prices in King County. Both our histogram and our box plot show that the housing prices are right skewed. The average price for a home in King County was $540,088. The minimum house value was $75,000, and the greatest value was $7,700,000. We created a heat map of home prices in King County to see if different zip codes had different housing prices. And we definitely noticed that certain zip codes had higher priced homes. We believe this might be because some of the Fortune 500 companies are located within these zip codes, or that there are suburbs around these zip codes that many of the people working for those companies live. We created a histogram for each of our independent variables. Some of the important findings that we found was that, on average, homes were 2,079 square feet. Most homes had one floor, and on average, 1.5 floors. Most homes had 2.5 bathrooms, and the average lot size was 15,106 square feet. On average, homes had 1,788 square feet above, and the median amount for the number of bedrooms in a home was 3. The average grade was 7.65, and the histogram for age shows that more homes are newer rather than older. For our data set, we had 2 dummy variables and 1 interaction variable. Our 1 dummy variable was basements, whether a house had a basement or did not have a basement. Most of the homes did not have a basement. The other dummy variable was renovation, whether a home had been renovated or not renovated, and most homes were not renovated. And our interaction variable was waterfront, and most homes were not waterfront properties. We chose waterfront as our interaction variable because we believe that there would be an interaction between price per square foot living and square foot lot, that being a waterfront property would increase the value of each additional square foot more than not being on a waterfront property. We also looked at how over time, the average price of each home and the average price per square foot has changed over time. We noticed that both were on an upward trend since February 2015. We also looked at how the average price of a home with a waterfront property versus homes that did not have a waterfront property. And we found that homes with a waterfront property had a higher average price. We also looked at the average price of homes that were renovated versus not renovated, and homes that were, on average, homes that were renovated are worth more money than homes that were not renovated. Our objective in Part B was to understand how the different variables interacted to predict housing prices. And then we'll discuss our takeaways from our results. We ran a regression with price and each of our independent variables. We predicted that homes with a waterfront property would be positively correlated with price. We also thought that renovation would be positively correlated with price. We also predict that homes with more bedrooms would be the bedrooms would be positively correlated with price. The bathrooms would be positively correlated with price. We also thought that price would be correlated with square foot lot. We thought that price would be negatively correlated with age, and that price would be positively correlated with square foot living.
After we compare the correlation result with the predictions, we create this correlation table. You can see the square foot of living has the highest correlation with the housing price, which confirms our expectations. And also the age of housing, the house is the only variable has a negative correlation with the housing price. Then we build our multiple regression model to predict the housing price. We can see the adjusted R-square is good. The overall model is good. These variables are good predictors because most p-values are close to 0 except the square feet above, which is 0.2908. In this model, adjusted R-square is 0.6635, which means 66.35% of the variation in the housing price is accounted for by variables listed in this model. Thus, about 33.65% of variation in the housing price remains unexplained. Each coefficient of the variable has some meaning. The coefficient of square feet of living means that holding all other variables constant, every additional square feet of living expect to increase the housing price by $157. The dummy variable renovation means that holding all other variables constant, the house with renovation on average expect to be $23,562 more expensive than the house without renovation. The interaction variable waterfront multiple square foot of living means that holding all other variables constant for the house close to a waterfront, on average, every additional square feet of living expected to increase the housing price by $354 more than the house without a waterfront. Afterward, we want to see what's the confidence level of the average housing price in King County area. According to the model and analysis, we are 95% confidence that the average housing price in King County is between $535,284 to $545,080. Later, we want to do some hypothesis testing to test whether some variables are significant in our model. First, we want to test if square feet of lot is a significant factor in determining the housing price with 90% confidence level. Our null hypothesis is that the square feet of lot is not a significant factor in determining the housing price. Our alternative hypothesis is that square feet of lot is a significant factor in determining the housing price. The alpha value is 0.1. Our p-value of square feet of lot is 0.2908. Since the p-value is greater than alpha, we fail to reject the null hypothesis and conclude that there isn't enough evidence to support the square feet above as a significant predictor of the housing price. Also, in addition, we want to test if square feet of living is a significant factor in determining the housing price with a 99% confidence level. Our null hypothesis is that square feet of living is not a significant factor in determining the housing price. Our alternative hypothesis is that square feet of living is indeed a significant factor in determining the housing price. The value of alpha is 0.01. Our p-value of square feet of living is really close to 0. So since the p-value is smaller than alpha, we can reject the null hypothesis and conclude that the square feet of living is a good linear predictor of the housing price. Finally, we want to see whether our model can really predict or can see some real data, the price of the house from the real data. Then we found some data on a new house. We put this data in our model and could get a predicted housing price. Like there's a house has 4 bedrooms, 3 bathrooms, has a square feet living 1,960 and 5,000 square feet lot. There's the 1 floor, the condition is 5, the grade is 7, 1,050 square feet above, and with a basement without renovation has 49 years old. Later, we predicted that the housing price, the price of this house is $494,780. The predicted price is pretty close to the real price, actual price.
Some of the key takeaways of our results was that housing prices and the price per square foot was on an upward trend. Thus, it might be a good idea for people to invest in a home now because their values seem to be increasing. We also found that location seems to be an important factor in housing prices. However, it wasn't accounted for in our model and may help to explain some of the error in our model. We also found that there was an interaction between waterfront property and square foot living and lot. We also found that the homes that had been renovated were worth more than the homes that were not. Thus, those who are looking to add value to their home should consider renovating, but should not have a budget of more than $23,562. The amount of money renovation adds to the value of your home. Interestingly, our model also suggests that older homes are worth more. This may be because there are fewer older homes, so the demand is higher, or the older homes are also located in the zip codes with the higher average priced homes. This concludes our presentation. Thanks for listening.